Good afternoon and welcome to the 2 o'clock demonstration of the QIF 2.0. QIF 2.0 is a new interoperability standard. So information incompatibilities are costly. They affect our supply chain. Our inspection data is usually provided in non-intelligent PDF files, and QIF provides us a faster, better, and cheaper solution. For Lockheed Martin, what I would hope is that we will be able to take the native CAD plus the PMI, the tolerancing information, provide measurement plans through our supply chain. They could provide us with the results back from those, and we will be able to do SPC analysis and improve our manufacturing processes. What you will see in this demonstration today is various users that have come forward and participating in this demonstration. They will either produce or consume a model-based definition in the QIF format, and or produce or consume a plan utilizing resources and results, or rules, I'm sorry, and then we will execute those plans through either a manual or an automated inspection system and take those results and perform SPC analysis with it. So we utilize a common library and the library consists of the documentation with the model-based definition, the plans, the resources, the rules, the statistics, and results. So again, today, various different vendors, I believe we have like 13 either producing or consuming one of these QIF entities. So on to the presentations. Today we have Mark Nielson of PTC talking about the Creo solution.
Thank you, Ray, and the QIF for including us in this presentation. So my name is Mark Nielson. We're going to kind of go through the CAD model here that we created using annotation features and elements for designing the model. So this model here was created to the MIL standard 31000 schema, where we have certain combinations of items at the bottom here. You'll see these various tabs that are set up that show different layouts of the model. This is for the typical model-based definition. Here you see what we call the site map. This is a general layout where we show things like the properties. Those are shown in the model. So not only do you have the geometry, but here we show more or less the envelope dimensions and the mass or the weight and the material. They're set up for things like the notes. And once again, this whole design schema is per the MIL standard 31000 Appendix B. And so you see things like these are the model notes. There could be flag notes and a number of other items in there. And then number 5 here is where we have the datums. So these are the datums used in the geometrical dimension callouts, and they're typically in this model in one consolidated place so you can find them. In addition to that, they're also in each one of these things. If we go back to the site map, you'll see the model is broken up into different areas that are annotated. So if you want to see the angled plate, you would go to 7C here, and it will show you all the dimensions, or at least the non-standard dimensions for that plate. And you'll have things like the profile call out, the angularity, the reference frame that are associated to that. And that's the typical modeling paradigm for model-based definition. These annotations are related to the geometry per ASME standard 14.41, where you have the annotations moving with the model as you rotate it, and they're specified on certain planes. So once again, this is a Creo parametric software that just where we've developed the model and show the different pieces in there that will be used downstream in the rest of the quality and inspection process. And with that, I'd like to thank the group, and I'm going to pass it on to Lyle here from Capvidia.
Thank you, Mark. My name is Lyle Fischer. I'm with Capvidia. Our contribution to QIF is we actually brought the model-based definition into the QIF format. So what I'm going to show you today is I'm going to take what Mark has shown you in PTC. We've developed a special add-in for Creo where we can actually take this fully model-based definition, and with a click of a button we're going to export it to QIF format and thereby reproduce a QIF model complete with model-based definition. And I'll show you our model-based definition viewer and visualizer, which, as you can see here, this is the QIF file that we generate out of Creo. It's now brought into our software to visualize. What's important here is that, first of all, we have all the geometry representation exactly matching what was in Creo. We also have maintained the full semantic links between the PMI within in Creo and the model geometry. So if I go through, I can show you here. We have all the combination views as well, as Mark was showing you. I can highlight the GD&T. You can see that we maintain the semantic links to the geometry and the PMI. And all the views, all the combination views, as in MIL 31000, also being maintained within QIF. We automatically generate QIF features and QIF characteristics, which are also part of the QIF data model. This model now is ready to be consumed by other vendors here that utilize QIF. And with that, I want to pass the microphone to Curtis Brown from Honeywell.
All right, thank you, Lyle. As Lyle mentioned, my name is Curtis Brown. I'm from Honeywell Federal Manufacturing Technology. That group manages our national security campus in the Kansas City area. And as a manufacturer, we recognize that quality has some issues. And those issues are incompatibilities in our information. We recognize it's costly, affects everyone, not only us as manufacturers, but our vendors, suppliers, users, and customers. And that reason is because until now, there has been no enterprise-wide standard solution. And so we're excited about the QIF, and that's why we're interested in the QIF, because it provides a superior standards-based approach. Also, as a manufacturing entity, we're very interested in the QIF because it will enable manufacturing quality to participate in model-based enterprise. So that's why we are interested in the QIF. Today, my role is to demonstrate the generation of some quality measurement plans. And those plans will be from a model-based definition. And I'm going to be using something that we have created in our facility called feature-based tolerancing, or FBTOL. So my role in the workflow of producing digital product validation is to take a product model or a derivative product model and determine the measurement requirements in the QIF format. And basically that format lists the measurement scope, or bill of characteristics, as some people know, may know that as that, all in the QIF format. So I'm going to use this FBTOL technology. Basically the intent of FBTOL is to augment solid models with PMI, or fully semantic tolerance information, so that we can check it. And here's an example of a score where a particular part's tolerance definition got a score of 87, where what we're really after is a 100% score. And so that's what FBTOL is about, but it also can generate model-based quality plans, or the bill of characteristics. So here we go. I'm going to go into the application. As mentioned before, this is a derivative model from the Creo model that you saw earlier. The PMI is shown here. What I want to do is just run the checker and validate the PMI is semantically correct. In this instance, it's a 100% score, and I have a fully green part. So I feel confident that I can create a measurement plan. So now I'm going to quickly create a QIF measurement plan in the QIF version 2 format. And here we go. And quickly, I've produced a plan, a QIF document of 1,284 lines. And we should look at that. So the document generates a .QIF file, okay? And in that is some version and header information. One of the things highlighted here is something called a QPID, which is basically a universally unique ID. So that uniqueness is universally unique throughout the known universe, right? That provides us some unique capabilities for feedback and things like that. Inside a QIF plan is datum definitions, datum reference frames, product information about as a printed drawing or as a digital model. Characteristics, that's our term for tolerances. You can also have not only dimensional tolerances and geometric tolerances, but maybe grain size or color. Those are characteristics that you need to worry about. And then here's the measurement plan. So I'd like to challenge you to encourage your favorite vendor to know about the QIF, work with your metrology department, make them aware of the QIF, and then if you're willing, join us as we progress that. Next, I'd like to introduce Bob Stone of Origin International, and he's got some exciting things that he wants to share with us with the QIF.
Thank you, Curtis. I'm Bob Stone with Origin International. We're a software company. We've been involved with standards development since the days of DMSC 3.0, and we've participated in the QIF development effort since its inception. The main, oh, I forgot my glasses. Origin's main product is Checkmate, which is a CAD system add-on that allows for offline programming, loading results in for graphical reporting and analysis. This program you see here in AutoCAD is the one that's been posted to DMSC to run on the Equator. We also have an add-on that works with SolidWorks. But what I want to show you today is the Checkmate runtime engine. It takes a inspection template from Checkmate, we call the process authoring, and it's being used with the Renishaw Equator. When the Equator program is finished, it generates DMSC format results, which the runtime engine then marries with the information in the Checkmate program, which includes this persistent ID that Curtis was telling us about, and it produces a QIF results file. You'll see those QIF results files being consumed by several of the vendors, and there's one that's just appeared on the monitor. The other thing I want to show you is a QIF universal translator that we've been working on. Here is a QIF plan generated by Curtis Brown with his FBTOL application, and dragging it and dropping it onto the translator, it automatically generates an executable DMSC program from that. We can do the same thing with the plan developed from Capvidia. This is actually just the model-based definition. The planning stage happens automatically inside the engine. The other thing it does is it takes non-QIF format results and translates them. For instance, here we have a DMSC format results file that happens to have been exported from PC DMSC. And if I drag and drop that onto the translator, it gets converted into QIF format results. We can also do the same thing with actual results from Zeiss Calypso. And we plan to support all 30 or so native formats that Checkmate currently supports. And with that, I would like to pass the microphone over to Sam Golan from PAS Technology.
Thank you, Bob. Good afternoon. Sam Golan from PAS Technology. We are a 2D, 3D inspection automation company which can automate any 2D data, 3D like SolidWorks, CATIA, or any other data like ProE and Siemens. We will focus today on the what we call the 2D inspection, because we talked about model-based inspection, but I would say a big portion of the industry is still getting IG-step and 2D prints, and usually you have to take and deal with the 2D prints, and our part in the QIF in this session is to extract automatically all the data from 2D prints and convert it to a QIF information. So actually what we do here, we are taking this part and we are assume the process kind of automatically, and we're going to run the process for about 1 minute, and I will not let you look into this screen for 1 minute, and I'm going to jump to another screen. But the idea is that once it's done, you're going to have this all data. Let me go again here so you will see it clearly. You're going to have it automated and balloon, and you have all the data structure down here extracted directly from a 2D print into the QIF standardization. And this data that we generated directly from a PDF will serve the entire process downstream. So now any CMM step which going to take it will create the process more accurately with the QIF or the inspection plan that we are creating in, actually to eliminate a lot of interpretation by user when he does it manually. And definitely this can be output as a QIF. As you see here on the screen, there is export QIF, and you can output it to the next step for this process. So at that point, I would like to transfer it to Peter at IPI. Thank you.
Thank you, Sam. Let's just get hooked up here onto the monitor. So just get the screen on view. Okay, so it's connected. There we go. So I'm Peter Swanborough from IPI Solutions, and we've been working with the other hardware and software vendors to bring the QIF standard to fruition. And the Visual IPI is a platform for making those reports, the first article inspection reports, the PPAP reports that customers typically want to see. So here we have a part that we have ballooned in visual fair, and for this instance we've taken a 2D PDF drawing for this part. We can use a 3D model-based definition also, but for the purposes of this demonstration we've taken a 2D print and itemized and identified all the characteristics and flowed those out into a particular output, in this case the aerospace first article inspection report form, and we don't yet have any results. Now what we're going to do, we're going to take a set of results that have been prepared from the equator through the origin software that they've output in QIF format. So I'm just going to run a QIF application, and this is going to allow us to open the results file produced by Origin, and we're going to be able to read in the results using the QIF format. Now, the reason that QIF is important to us, presently we can bring in results from most CMM devices, but there is individual unique programming per each device, whereas the QIF gives us a standard format. And QIF allows us to import results prepared by others, or we can export our own QIF file for consumption by other applications. So if we go and take a look at that part again, we should see that we've been able to directly input the results from that QIF file. And there we go. So the traffic light system showing us that we've got some good results, some out of tolerance results, and also the orange is telling us that we need some results that maybe we're going to collect manually, not from CMM. And that information is pushed through out into the report, and it could be displayed on any report that we need to send out to customers. So the quality information framework is very important to us to make sure we've got a standardized format for the flow of data from CMM back into our software application. So now I'd like to round off my part of the presentation and hand over to Gabriel from another software vendor called Kotem. So thank you.
Thank you, Peter. My name is Gav, and I work with Kotem, and today I'm going to tell you about our software called Smart Profile. Smart Profile evaluates all the GD&T callouts on your part. It doesn't matter what standard you use, ISO or ASME 9094-2009. We cover all these and all the callouts that come with them, all the complex GD&T, compound datums, multi-segment and FCS. So the typical workflow in our software is we typically import the CAD model, apply the tolerances, import points, and run an evaluation. However, with the introduction of QIF, we can make this whole experience much smoother for our users. And what they will need to do is just import a QIF file that contains all this information, and then we will output the results file, which will contain the different results that we obtained for their feature control frames. So again, we'll be consuming QIF MBD from vendors like Capvidia, and produce QIF results, and also consume QIF results from vendors such as Origin. In this case, for this QIF demo, we're still in the process of developing the QIF MBD importer, but I'm going to show you how we import QIF results and output QIF results in our software. Typically, a user would have to go into the drawing, look at the feature, try to find the call out for it, and then enter it. Like so. Which in our software is somewhat straightforward, but it's still some work. So you'd have to go here, let's say 0.5, and then choose your datums. And with QIF, all this is done for you. Let me just show you how this works. So I'm going to automate this. Here, where it asks me for a QIF file, it's over here. If we have multiple QIF files, we can import them one by one and run an evaluation. Then it asks me about an output folder, so I'm going to choose that as well. And here it is, the model. We can see the GD&T that we would like to evaluate, and you saw how the points got right from the measurement device into the model, and we have our results right here. With this, you can automate the evaluation of all the parts that you're interested in, and all of them will be output into QIF files, which can be later analyzed via SPC software. And with this, I would like to pass on to Daniel Campbell from Metrosage.
Thanks, Gav. So my name is Daniel Campbell, and I'm with Metrosage, and I'm going to be talking a little bit today about our Pundit CMM technology and how we use QIF right now as a method for inputting our data and outputting our data. Now, a little bit of background on what Pundit CMM does. We calculate task-specific measurement uncertainties associated with your CMM measurements. So an example would be right there, that a diameter tolerance on a specific feature. We would have a measurement uncertainty for that value. Here are the inputs and the output from our Pundit CMM technology. The output, obviously, is the measurement uncertainty. And inputs, we require information about the feature geometry, information about the GD&T or the tolerances that are applied to each of the features, information about the sampling patterns that will be taken by the CMM, some information about any manufacturing error signatures that might exist on any of the features, and finally, the measurement system that you're going to be using, what measurement equipment. Now, QIF is very, helps out a small company like ours quite a bit, because all of this information can now come from QIF. Previously, we have to get all of this information from separate sources or rely on an engineer to be entering the data manually. So QIF is a big boost for a downstream application producer like ourselves. So what I'm going to be showing you is a module that we've created called Pundit Black Box, which is a very simple tool that takes in QIF data and calculates measurement uncertainties. And so we will be taking a QIF results that came from Kotem software, and we'll be calculating measurement uncertainties for it. So here is a QIF file that came from their software. This is results from a real measurement. It's a .qif file, and here is this file loaded up on our system. Here we have a list of some of the measurands that we will be evaluating. So I'll go ahead and run a new simulation. And here we go, as simple as that. We start to see measurement uncertainty values associated with each of the measurands that will be measured on your CMM. And again, all of this is made very, very easy with the QIF format. So with that, I would like to pass it to Borja from Innovalia.
Thank you. All right, so my name is Borja de la Maza. I'm here representing Innovalia Metrology. So we are a group that we make software, but we also do CMMs. So this is a particularity as well regarding the rest of the group in the standard. So we are interested here to give our customers the possibility of exporting results as well as importing. Our main difference in our product in terms of M3 software is that we can capture, store, and analyze the data coming mainly from 3D scanning systems. So we are able to perform GD&T directly in a cloud of points. And this is where we come along regarding our workflow, where we are capturing, doing the analysis, and performing an output file in QIF. We would like as well in the future not only being in downstream, but as well introduce more model-based definitions regarding the STL and the cloud of points, as well as the resources that we'll do in the next steps. So if you want to see a real live demo with our CMM and our scanner exported in QIF, just come by our booth at 4732. Thank you. And now I will introduce Simo from InfinityQS.
Thank you, Borja, but my name is Simo Kinkalvik. I'm with InfinityQS International. Our involvement in the QIF is to be able to consume the results, to be able to get data from various different pieces of equipment, whether that equipment is our CMMs or various other measurement type of systems. So I do want to make a point that it's not just CMM, so we can get data from other sources, whether that's manually entered or it's coming from vision type machines or CMMs or from third-party inspection houses, maybe your suppliers, or maybe you have multiple different types of CMMs and multiple different pieces of equipment within your own organization that you'd like to be able to consume and combine and take a look at that data for analysis purposes. So that's the part that we're really excited about as an organization, as InfinityQS, is that we can actually take data very easily from these different sources and just combine it all, consume it all, be able to do the analysis, take a look at it in various different ways. So I do have an example of this, and what I have is just a bunch of different QIF files, and they're actually coming from this origin setup that they have here from the Renishaw equator. We've been measuring this part here for a couple of days now, so we got a bunch of different files, but you can actually kind of imagine that all of this data has been something that we've been measuring over a few days, maybe in a couple of different CMMs, maybe not, whatever it may be. But what I'm going to do here is I'm just going to grab about 20 or so files and consume them all. And so hold on one second, I got to hit the shift key. Sorry about that. And so what I'm going to do is I'm just going to copy these, put these in a different location so that our reader can pick up all these files and consume them. And as you saw, they just dropped away and they've been consumed. Now, as soon as they've been consumed, and actually what I want to do here is show it to you in a little bit of a different type of dashboard just so we can see this, and maybe not. Okay. But essentially what I wanted to show is all of that data has now been consumed. It's all in charts and reports, and we can do our analysis on this data and be able to take a look and see what's been going on and for the part that we've been measuring all morning and different things of that sort. So what we have here is just a control chart displaying our data for one of our characteristics here. We have our statistical indexes, our CPs or CPKs or PP, PPK, that sort of thing. We can take a look at the data and things like a box and whisker plot to take a look at all of our characteristics at once and kind of see where they're at in regards to our specs. Are we running high, running low? Which characteristics are giving us trouble? For example, here, characteristic 71, it's a little bit below spec limit. This is actually one of the hole diameters. That's a bit below spec, but that's okay. We can also take a look at some of this information in some of our more of a summary type of analysis. Take a look and see if there were any alarms, when they occurred, those sorts of things, and also maybe like a capability summary report to understand where our capability's at and those types of things. Also things like histograms. In this case, we're very good. As you can see where our spec limits are at and where our data's at, we're doing very well. And those things are to be expected. We've been measuring the same part. But I do want to talk about this is a great way to be able to get data from various different sources, combine it very easily, very quickly, very little setup at all, just consume the files, it's almost plug and play. And with that, I do want to turn it over to Mr. Robert Brown from Mitutoyo.
Thank you, Simo. My name is Robert Brown, I'm with Mitutoyo America, and we've been doing digital metrology for about 30 years. And more recently, we've been supporting the model-based enterprise and interoperability standards in as that it saves our customers time, money, and increases their accuracy. So for my part of the demonstration, what I'm going to do is take the Measurelink SPC data management application and take a plan as derived from the upstream Creo QIF widget, consume the plan, map it to a caliper as a dimensional metrology equipment, and output statistics that will be consumed downstream in an MTConnect dashboard. So within our routine library, our part library, I just have to import that plan. And you'll see what it does is it brings in 4 distance between characteristics that I'll be measuring on this part. Bringing this in straight from the model through the plan prevents an operator from making the mistake in spelling the characteristics label and providing the nominal or tolerance information. The only thing I need to do before collecting data is tell it where the information's coming from, and I'm going to tell it to come from the 6-inch caliper on my USB port. So once it's mapped, I'm ready to collect data. So we'll go to our real-time application. And I have a study, a 20-piece capability study that I already have up, but I'll go ahead and make my 4-dimensional measurements. So you can see in just a few minutes, I was able actually to acquire data against the dimensions called out on this part by a plan designed for the caliper. The last step, again, to take that plan through execution to the results and statistics is to very simply output it. Whether it's through an export mechanism or through a web service. As an example, this output on a capability study with its results and summary statistics can be shown as an example in the MTConnect dashboard. So any downstream consumer, ERP, PLM, or a simple dashboard can bring up that information, and you'll see here the actual data with tolerances, CP, CPK, process capability, max, min, standard deviation, and the raw measurements themselves. So as you see, from upstream to downstream, QIF supports all of the workflow for enterprise metrology. And with that, I'll pass it on to my colleague, Will Sobel from System Insights.
Hi, I'm William Sobel. I'm CEO of System Insights. And we developed the Amana product. And I actually wear two hats. One is System Insights. The other one is I'm chair of the MTConnect Institute Technical Steering Committee, so I developed the MTConnect standard. What we do at System Insights, we develop an application that collects real-time data from the shop floor and then analyzes it and tells you when you're producing, when you're not producing, and why you're down when you're down. We also have rich analytics around that data, where we can go into things like your cutting tool, whether you're deviating from plan. We can get into cycle time and validation of whether your cycle time is on time and so forth. So I'm going to talk about a little bit more here is MTConnect. So MTConnect is partnering with DMSC, and we are going to be, in the next version, carrying the QIF data. What this is going to allow us to do is to be able to allow any system to get access to it in real time. Right now what we do is we carry things like machine tool data, your process information and so forth, and we can calculate simple things like utilization. We can also do produce let me see, cutting tool information. Application, if something has it, 1 second. Getting slow. Oops, not up right now. Bad demo. Oh, cutting tool tab isn't there, but we can also analyze cutting tool data and carry that along with the MTConnect as well. So the big change here is we're now able to carry, as Bob just showed, quality data as well. And this is going to be a big advantage to MTConnect. It means that you can now get a full set of what's happened in your process, all the way from your first machine tool when the part entered the machine tool to measurement, on-machine gauging, all in a standardized format. That means that any application that can consume this data, whether it's MTConnect, QIF, cutting tool data, we even carry ISO 13399 for cutting tools, or Metrology for QIF, you can get insight into your manufacturing process that was never possible before. This is going to allow for new applications, new areas of innovation that haven't even been thought about. I mean, if you look at like Industry 4.0 in digital manufacturing, this is what's going to be able to enable that. A combination of things like MTConnect and QIF are going to be the way the industry is going to be able to take the next step in the future of manufacturing. With that, I'll hand over to Mike.
Hi everyone. My name is Hui Huang from the National Institute of Standards and Technology, or NIST. It is within our mission to support smart manufacturing, next generation manufacturing. And so the standards on information models, standards on interfaces are among the key elements. We believe that these standards could help the manufacturers to focus your resources on productivity rather than data incompatibility. Therefore, we plan to continue to be fully involved. And we invite you to join us in the QIF development effort. With this, I'd like to turn the mic to Ray for wrapping up.
Thank you, Ray. So again, I'm Ray Admire with Lockheed Martin Missiles and Fire Control. I'm a quality engineer. So what you have witnessed here today is several companies, about 13, that are working in the collaboration of our consortium to help provide solutions to our customers, which means we can now take data in a non-proprietary format, all the way from the product definition to the analysis of results. The DMSC is a not-for-profit organization. We have several different membership capabilities or options for you. We are focused on and relating to dimensional metrology. We are ANSI accredited, and the 2.0 QIF that you witnessed here today is just last Friday released for public review. So we hope to have all of these complementary parts of the standard at a full release standard by January. So at this point, this concludes our demonstration. Thank you for your time. We will do our demonstration again throughout the week at 10 and 2 in the morning. Here are our DMSC consortium members and associated organizations working for QIF. So again, a cheaper, better, faster way of helping us, the quality folks, become more useful to our manufacturing processes. Thank you for your time. Thank you.